this video, I intend to go over how to find the mean, median, and mode of a set of data. First, let's review some vocabulary. The definition of mean is the arithmetic average of the data. In other words, you add all the numbers together and divide by the total number of numbers. The median, the number exactly in the middle of the data. When the data has an odd number of counts, the median is the middle number after the data has been ordered from least to greatest. When the data has an even number of counts, the median is the arithmetic average of the two most central numbers after the numbers have been ordered from least to greatest. And mode, the most often occurring number in the data. If there are two or more numbers that occur equally frequently, then the data is said to be bimodal or multimodal. Example 1. Compute the mean, median, and mode for the following set of data. Let's first calculate the mean. So what we're going to do is we're going to add all these numbers together. So that'll be 1 plus 4 plus 5 plus 7 plus 6 plus 8 plus 0 plus 3 plus etc. And we can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. 33 numbers. So we're going to use a calculator and add all these numbers together. So that'd be 1 plus 4 plus 5 plus 7 plus 6 plus 8 plus 0 plus 3 plus 2 plus 2 plus 3 plus 4 plus 6 plus 5 plus 7 plus 8 plus 9 plus 0 plus 6 plus 5 plus 3 plus 1 plus 2 plus 4 plus 5 plus 6 plus 7 plus 8 plus 8 plus 8 plus 4 plus 3 plus 2. When I add all that together, I get 152. I'll divide that by 33 for the total number of numbers, and we get our mean to be 4.61. To calculate the median, the first thing we need to do is put the numbers in order. So we have 0 looks like our smallest, then 1, see if there's any other ones, 1, then we have 2, 2, another 2, let's see if there's any other 2s, another 2, and then we have 3, another 3, we already used that, there's another 0 I forgot, another 3, and then we go to 4, let's see, I missed the 3, so we have to add that in. Let's make this a little bit neater. 3, and 4, another 4, another 4, and another 4. Then we have 5, another 5, another 5, another 5, and then we have 6, another 6, another 6, then we have 7, another 7, another 7. Then we have 8, 8, 8, and another 8. And I believe I missed a 3, so we'll add that 3 in. There should be 1 and 9. So we'll add that extra 3 in here. So if we just cross out so we get to the middle. Cross, 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 and our median is 4. Now the mode is just the number that appears most frequently, and now that we have them all in order, it's easier to pick it off. So we have 1, 2, 3, 4 2s. See that we have anything higher than that. 1, 2, 3, 4, 5 3s. That's the contender. We have 4 4s, 4 5s, 3 6s, 3 7s, 1, 2, 3, 4, 5. So the mode looks like it's the tie between 3 and 8. The cost of fresh blueberries at different times of the year are $2.50, $2.99, $3.20, $3.99, $3.99, and $4.99. If you bought blueberries regularly, what would you typically pay? So this problem, when we use the word typically, we're implying the word typically implies mean. The word typically implies mean. So what we're going to do is we're going to add 2.50 together. Our numbers, let's highlight our numbers so we can see them. 250, 299, 320, 399, and 499. Plus 2.99, plus 3.20, plus 3.99, and 4.99. And we know that there are 1, 2, 3, 4, 5 numbers. So we're going to put a 5 at the bottom of our fraction. $2.99, $3.20, $3.99, and $4.99. So first let's add the top. So 2.50 plus 2.99 plus 3.20 plus 3.99 plus 4.99 on the top. That simplifies to 17.67 over 5. So the top is just simplified to $17.67. The bottom is still 5. The last step, you just divide. 17.67 divided by 5. So your typical price is $3.53, and we are done. Example 3. 5 people were called on a phone survey to respond to some political opinion questions. 2 were called from zip code 94061. 1 person was from the zip code 94305, and 2 people from the zip code 94062. Which measure of central tendency makes the most sense to use if you want to state where the average person was from? This is a trick question, as we are taught zip codes are categorical data. So Measures of central tendency do not make sense to use. Measures of central tendency do not make sense to use. And we're done. Example 4. You write a computer code to produce a random number between 0 and 10 with equal probability. Unfortunately, you suspect your code doesn't work perfectly because in your first few attempts at running the code, it produces the following numbers: 1911929199922. How would you argue using mean, median, or mode that the code is probably not replacing a random number between 0 and 10 with equal probability? So let's first find the mean. So the mean, we just add all the numbers together. So 1 plus 9, etc. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 numbers. So we add all the numbers on the top. 1 plus 9 plus 1 plus 1 plus 9 plus 2 plus 9 plus 1 plus 9 plus 9 plus 9 plus 2 plus 2. And that gives us 64 on the top. Divided by 13. We'll use the blue to indicate the bottom. And we'll use the green for the numbers on the top. And this is the simplification. Now we divide. And we get a mean of 4.92. So by itself, the numbers are around the mean. So that's not enough to argue that the machine's broken. So now let's find the median. Put them in order. 1, 1, 1, 1, 1, 1, 1. And then we have 2, 2, 2. Then 9, 9, 9, 9, 9, 6 nines. So now we use a cross-off method to find the median. Work our way to the middle. And our median is 2. This is ironic because the majority of the numbers, so this does indicate there could be a problem. This one doesn't, not enough info here, since there is data around the mean. But since there's only a few 2s and there's more like 1s and 9s, the median does indicate that there could be a problem. Let's check out the mode. The mode we can see is 9, and every data set has a median, so that's not enough information. Not enough information to determine that there's a problem with the machine. But by looking at all three, we can see by the median that could tell us that there's a problem with the machine, because the median's 2, but we clearly have a lot more 9s than there are 2s. The Wacky Widget Company has 15 employees. The jobs, annual salary for each job are given in the table below. A newspaper reported average Wacky Widget workers earn $78,000 per year. What statistic is being reported? The mean, median, or mode. So let's first look at the mode, because that's the easiest one to pick off this set of data. Let's use yellow for mode. So the mode, let's see, what's most frequent? 1, 2, 3, 4. I have 4 65s. So it appears like my mode would be 65. $65,000. So we're not reporting, this newspaper report's not reporting the mode. So next, let's find the median. So let's scratch that. Let's do mean next. So what that means we have to do is add them all together. 380,000 plus 35,000 plus dot. All that over, there's 15 employees. And we'll use pink to represent all these numbers. So add them all together first. 380 plus 35 plus 150 plus 30 plus 90 plus 30 plus 30 plus 27 plus 24 plus 24 plus 90 plus 65 plus 65 plus 65 plus 65. And we get 1170 on the top. All that divided by 15. And last step is just divide. 1170 divided by 15 is 78,000. So it appears that it might be the mean being reported, but let's just double check the median. Okay, so let's put them in order. 24, 24, 27, 30, 30, another 30, then a 35, then 365s, then 290s, then 150, and then 380. So let's find the median. Cross until you get to the middle. So the median is $65,000. So the reported statistic is the mean. So the reported statistic is the mean. Now, part B. Why might most employees be upset by the newspaper article? Remember, the newspaper article claimed that the average wage was $78,000. So for part B, if we look at all the data, we see that 78,000 is the mean, but we only have a 90,000, 150, 380, and 290s, most of the employees are making much less than the mean. So that's why somebody applying for this job might be upset about this reporting. Well, so we can say the average, most employees, let's say most employees make much less than the average reported wage. So therefore they would be upset. And we're done.